we've had fish tanks that smell high heavens. So many minutes. That's that ammonia smell, right? That smells like urine, right? Or decomposing material in there can smell really bad from like methane gases that are released. Stick 30 plants in there overnight. Cleans it up, smells fine, pH bounces out, and the water almost turns clear. What's that?
It's like farmers when they use the clove in their plants.
Yeah.
Do you mean like have this system or literally stick a plant in the tank?
Just like this.
Okay.
Yeah. But we've had beds of collard greens and cucumbers and lettuce that you can almost stick right into. You can stick them right into the water, and they'll grow. Yeah. What else about this system could I tell you now? It's cool to have a bottom feeder in there, a Placo or something like that, or some crayfish. They keep systems a little bit cleaner.
And
Please.
also, when you put the roots into the water, they're giving off oxygen, a little bit of oxygen, back into the water too.
That's good. Yeah. Yes.
I've got a trout center for my classroom, from the hatchery.
Oh, yeah.
And I was just wondering, we have to keep it chilled, the water chilled for the trout. Is that going to affect the plants?
It's even better. What do we know about dissolved oxygen, water, and temperature?
The colder the water, the better, the more
The colder
gas.
the water, the more oxygen it holds.
It's like
So,
an experiment by itself with kids on hot water.
Exactly.
How much oxygen is in hot water compared to
Yeah.
cold water.
yeah.
But they keep
So
so cold.
you're going to be better off than anybody else because you already have colder
Carbon
water.
dioxide in
My
water.
fish will actually live for 1 year.
Yeah. Now, can you see how many different scientific standards we would hit?
Right.
Plus the technology standard, standard 8.2, and we're all Jersey teachers, right?
Right.
Standard 8.2 says that up to grade 8, there has to be a design, make, and build component.
Right.
Okay, on top of the science standards that we're hitting, and any measurement of how much water or nutrient am I adding, or ratios of plant mass, or measuring plant mass growth over time, all right, as compared to how much fish food are we feeding it, we're getting math standards in there too.
Right.
And I understand you're not going to cover every standard with project-based learning, not when you have so many things you have to cover for a standardized test, but we can cover a lot of them, and it can make for much more meaningful learning within a context. Is anybody's district really focused on understanding by design right now? They're doing a lot of UBD. And in UBD, they say that for a student to construct original knowledge, to really understand, 6 facets have to make up that understanding. Did they go over those with you guys? 6 facets to understanding. Students have to be able to apply. They should learn within a context. They have to have self-awareness, reflection, empathy for something and for something that's taking place for someone else, right? They have to analyze. Those 6 facets for understanding take place best in project-based learning, especially open-ended project-based learning. Let's look at the difference between the scientific process. What's that called? Where you do a hypothesis? Scientific method. Scientific method. We all build the same exact thing. And the only thing different for any one of us is our hypothesis as to how it's going to work, right? So everyone, we're all going to test 3 different kinds of wicks. Now you write a hypothesis. Which wick's going to work best and why? Where was the design in that experiment, in the scientific method? It wasn't really that much design. Everybody had to make the same thing. But now, if as a group, as a class, everyone does what they think is going to work best, and as a class we analyze and see which one really did work best, right? Doing a design and problem-solving process like that, okay, I think makes, again, for more meaningful learning.
Fortunately, the scientific method is being modernized to actually be more like the circle and sound more like the UBD method and process. It's being evolved. It's slow,
Yeah.
but it's actually more like that now than it ever was. Because it is acknowledged that you need to have those other things in component
and I
for try to
think
have
you have to have a
meaningful
scientific
learning.
method too. What's your name?
Katora.
Katura. So Katura, we do the soda bottle system, and once it's up and running, now we move into the experiment phase. Now let's make some hypotheses about each one of your systems you design and build, and let's track it over time. So part of the scientific method is observation over time. So every day a log is being kept, and every day I'm checking temperature, I check pH, I'm looking at the weather and how much sunlight did it get this week, and I'm putting all this into a chart. And as I do, I'm trying to say, okay, what do I think is going to happen to the plant next? And I'm actually watching how did these things that I observed affect the plant life.
Right.
We're measuring how tall the plant got. We weigh how much it weighed. We're weighing. We could take the fish out in the net and plop it onto a scale real quick and weigh it. Right? A lot of applications that can be covered through one project. And kids will take ownership over it too, because it's theirs, and they made it. Like I said, that fist fight that broke out in the classroom over 2 boys and their plant. Okay.